This question is about pressure. It says a student wants to calculate the pressure he exerts on the floor when he stands on 1 foot. He records these measurements. So he's got his weight, 650, there's no unit, and then the area of the floor in contact with my foot, 270 centimetres squared. Part A asks you to complete the table by adding the unit for weight. Weight is a force, so the unit is going to be newtons, capital N. Don't fall into the trap of confusing mass with weights. Lots of students will put kilograms here, but that is his mass. And no person is going to have a mass of 650 kilograms. That would be ridiculous. Part 2 asks which piece of equipment should he use to measure his weight. Now, don't get confused here and think that he's going to have to hang himself on a Newton meter. You would get the mark for that, but that would be slightly ridiculous. He can still use a weighing scale or a balance. And if it was in kilograms, all he'd need to do is multiply it by the acceleration due to gravity or the gravitational field strength, which on Earth is 10 meters per second squared or newtons per kilogram. So, here his mass would be 65 kilograms. Part B asks you to suggest how the student measured the area of the floor in contact with his foot. Now there's 3 marks here, so we've got to be quite detailed. So let's say that you placed your foot on the ground. It would look a bit something like this. And that's a bit of a clue. I would draw around the foot. Now, perhaps it'd be best to do that on some graph paper or some square paper. Then I could count the squares. Of known area to work out the actual area of the foot. Part C asks you to state the equation linking pressure, force and area. So pressure is equal to the force divided by the area. And now, as always, it wants us to use that equation to calculate the pressure that the student's foot exerts on the floor. Now, I always like to check with this sort of question what unit they want us to give the answer in. It is newtons per centimetre cubed, so I don't need to do any sort of conversion here. I can just substitute in those values into my equation. So 650 newtons divided by 270 centimetres cubed, put that into a calculator and you will get 2.4 newtons per centimetre cubed. So 2.4